we're going to build our first circuit using these boards. So think of this as a tutorial level just to get a feel for how they work. So on the tray, on the top level of the box that you've been sent, you should find a bunch of identical boards on the left hand side. On the right hand side are stackable banana cables. Some of them will have a kind of smooth cable, some have a twisted pair, and some have a nylon braid on the outside of them. That's to help with tracing circuits later. I'm going to use a 3.7 volt lithium battery for this demonstration, but I'm aware that I actually can't send you one because of postal restrictions. So I hope you have one around. And then in the middle of the tray is a plastic box. It has two clasps in the front, and that has the components that we're going to be using. You might notice that there's Velcro on the bottom of the box and the bottom of the boards. That's just to help keep it stable as we build the circuit. So if we go ahead and grab one of these boards from the left hand side, you'll feel that there's a block sticking out of the board's surface on its left hand side that has a little lever on it, and it has two channels down on its top surface. At the edge of the board, on the top side furthest away from you, are two connectors. One is a JST connector, so this little socket, and the other one is a 2-pin female header. And then right in the middle of the board are two banana sockets. So these are how we're going to wire our circuits together. Underneath the banana socket that's on the left, you should be able to feel a Braille V. That's the side that we're going to use for positive connections, so V for voltage. And underneath the banana socket on the right, you'll find four bumps, that's G, I hope it's legible in Braille, for ground. Underneath G, you'll find 3 bumps in a horizontal line, like a negative sign. So that's going to be our negative or our ground connections. And then underneath the V, you'll find 4 bumps in a cross shape. So that's like a plus for positive. Directly in front of those, you'll find 2 flat metal pads with a little notch in the front of it. That's just in case you want to connect anything with a crocodile clip, but it helps to kind of orient you to where the banana sockets are. They're straight in line with those notches. The last little feature is on the right hand side, on the short edge of the board, there is a circular notch, a semicircular notch cut in, and that will always be closest to the banana socket that is ground. Okay, so if you have a LiPo battery pack, they usually have a JST PH connector on them. And if you can find the JST PH socket that's on the boards, it'll be on the edge furthest away from you. If you want to connect the battery in there, if it doesn't go in the first time, it'll be like a USB key, or they have an orientation, so it'll only go in one way round. Once you've connected it, the banana sockets on the board should match to the polarity of your battery. So the positive banana socket is now connected to positive on the battery, and the ground banana socket is now connected to ground on the battery. So once we have one component connected to a board, we're going to treat that overall board plus component pair as a single module. So this is now going to be our battery board. I'm going to refer to it as our battery board going forward. So I'm just going to move that over to the side, and I'm going to grab a new board. So for this board, we're going to connect an active piezo buzzer to it. In the box of components that's in the middle of the tray, if you open it up, you'll find in the top row the row closest to the hinge. In the first compartment to the left, there's an active piezo buzzer. So with piezo buzzers, we can tell which leg is positive and which is negative by which one is longer. So you should hopefully be able to feel that they're two different lengths. The longer leg is going to be where we need to connect positive connections to. So on the second board that you've gotten, this block that's on the left hand side that has two channels in the surface of it and the little lever, we're going to make sure that the lever is pointing up towards the ceiling. That means that this connector is open. And we're going to take our piezo buzzer and we're going to make sure that the long leg is seated in the left channel or groove on the top of the block, and the short leg is on the right one. It doesn't matter where in the block it is, as long as positive is in the left and negative is in the right. When you have it sitting comfortably into it, hold it in place and push that little lever down. So that will lock it into that connector. If you can give your piezo a little wiggle, you can check that it's seated firmly. Okay, great. Now we're going to wire together our actual circuit. So if you want to use something like the nylon braided banana cable, I'm going to treat the nylon braid as our positive connections. It's just for tracing them. And I'm going to put this banana cable into the positive banana socket on the battery board. So into the positive, and then I'm going to connect that to the positive banana socket on the piezo board. I'm going to grab another banana cable. This time I'm going to use the one that's a twisted pair. I'm going to treat those as our ground connections. So I'm going to do the opposite thing again now. I'm going to pop that banana cable into ground on the battery board and into ground on the piezo buzzer, and we can hear we've made a successful connection. Okay, I'm going to take that out again. Okay, so that's the basic principle. I think we're going to add a button now to make sure that the buzzer isn't just going off constantly. So I'm going to take out these cables again. You don't have to. If you have a good conception of where the circuit is, you don't have to, but I like to be able to go through all the steps. I'm going to take a third board and pop it down here beside my piezo board. And in the second compartment of our components box, you're going to find two push button connectors, or sorry, tactile push buttons, the connectors. There's a small one and a big one. I'm going to use the big one, but either will work for this, so whichever you prefer. On the third board, I'm going to again make sure the little lever on that block on the side is pointing up towards the ceiling so that the connector is open. And holding my button, I can tell that my button has 4 legs. It actually only has 2 connections. These legs are connected in pairs. So we need to make sure that we're putting this, that the right legs into this channel on this block. So we're going to hold the button so that the 2 flat sides that have no legs sticking out of the button are to the left and to the right, and that 2 legs are pointed towards us and 2 legs are pointed away from us. While we have it in that orientation, I'm going to make sure that the legs are straddling that center rail of that block connector. So I'm going to make sure this fits snugly around that. I'm going to hold it firmly in place in that connector and push down the little lever. And again, we can give it a little wiggle to make sure that it's nicely seated in there. Okay, taking our banana cables again, I'm going to start with positive on the battery, bring it into positive on the piezo buzzer. Then I'm going to take another cable, maybe a smooth one this time. I'm going to connect it to negative on the piezo buzzer and then into positive on the button. In truth, the button doesn't have a polarity, so positive, negative doesn't matter for this component, but I'll put it to one side of the button. And then finally, I'm going to take a ground banana cable, so a twisted pair. I'll connect it to the other side of the button and then complete the circuit by going back to negative on the battery. And we can check if we've done that right by giving the button a little push. Lovely, great. Okay, so we're going to swap out some components on this circuit now just to try a different way of activating that buzzer. So I'm going to open up, sorry, I pressed the button. I'm going to open up the block by moving that lever pointing up towards the ceiling. And I'm going to take that button out and put it back in the component box. It's in the second compartment in the top row. And in the third compartment, we should be able to find something that's like a little tiny glass vial with two legs sticking out of it. The legs, depending on how they're bent, might feel like they have a slightly different length, but they don't actually have a polarity. This is a reed switch. So you can bend these legs a little bit if it makes things fit better, like wiggle them around whatever way you want. But with the board that had the button, that we just took it off, and with the lever on that block facing up towards the ceiling again, I'm going to put in this reed switch so that one leg is in the left-hand channel and one leg is in the right-hand channel. And then I'm going to close that down to clamp it in place. As always, you can give it a little wiggle. And then in the fourth compartment of the component box, you're going to find a metal circle with a hole in it. That's a magnet. So we're going to use that magnet and we're going to hold it over the reed switch. And you can see how the magnet turns that or closes that switch to let the power flow to the buzzer. Okay, great. I'm going to put that magnet back in my component box, and I'm going to take my reed switch out now and put it back in the third component. And I think now I'm going to dismantle my circuit again. So I'm going to pull out all of my banana cables so that I can wire it up fresh and make sure I'm doing everything right. So now I should have a board with a battery, a board with a piezo, and a board that's currently empty because I just took the reed switch out of it. I'm going to go to the board with the piezo buzzer, and I'm going to open that lever by pushing it up towards the sky, and I'm going to pop that piezo back in the component box. In the fifth box in the top row, we're going to find a resistor. This one is a 1 kilo ohm resistor. This may be a sort of a slightly pointless exercise, but just to show off the last type of connector that's on this board, we're going to connect an LED to it. And so that we don't burn out our LED, we're going to make sure that we're using a resistor first. So I'm going to, if I have my battery board on the left, I have my boards arranged in a straight line horizontally. Yours might be different. But I'm going to take one of these blank boards that has nothing in it now, and I'm going to pop the resistor into that connector with the two grooves. So resistors don't have a polarity, so it doesn't matter which way around it goes, just as long as one of the resistor's legs is in the left-hand channel and one of them is in the right-hand channel. And make sure to push that little lever down to like lock it in place and just check. In the sixth and final box in the top row, we're going to find what is a very big LED. So it's a gumball style LED. And on its two legs again, we can feel that one is long and one is short. So just like with the piezo buzzer, our long leg has to be oriented towards the left hand side of the board. So our left hand connections are always going to be positive and our right hand connections are always going to be ground. So we're going to use a type of connector that we haven't yet. And on this third board that's blank, so we have one with a battery, one with a resistor, and one that's empty. On the edge of the board, on the face, over to the right, just above the ground banana socket, you'll find a 2-pin female header. We're going to pop our LED into that. It's going to be maybe slightly tricky, but we're going to make sure that the long leg is in the left hole and the short leg is in the right hole. And I've got that in there. And now I'm going to wire up my circuit again. So I'm going to get one of my positive cables, my nylon braid cables. I'm going to connect it from positive on the battery to one side of, no, I'm going to put it to the LED. So positive on the battery to positive on the LED. Then I'm going to take another cable, any color or any, just one of the smooth ones. I'm going to go from ground on the board with the LED, so into the ground banana socket there, to one side of the resistor. Again, resistors don't have a polarity, so it doesn't matter which way around. I'm going to grab another cable, go from the other side of the resistor, that banana socket, and I'm going to connect it back to ground on the battery. And if you can see it, it's a little color changing LED, so it like runs through a little RGB sequence, flashing different colors of light. So that concludes all of the basic features of the 2-pin boards, and this is how you wire up really basic circuits in series. Just one other feature to draw attention to, which is, let's say I want to connect another component to this. So maybe I want to go back to my piezo buzzer. If I grab my piezo buzzer again and a fresh board, and I'm going to do the same as last time, I'm going to look for the long leg. I'm going to make sure that's in the left hand channel of the big block connector, and that the right leg is in the right hand, or the short leg is in the right hand connector. So a nice thing about banana cables is that they're stackable. So if you go over to the positive cable that's coming out of the positive banana socket on your battery board, you might be able to feel just where the cable goes into the plastic block of the banana like connector itself. There's a little hole right at the top of it. So not where the banana connector goes into the board, but where the wire goes into the plastic part of the cable. If you can find that hole at the top, we can add another second banana cable into it. So now we have two of them stacked vertically and both are connected to positive. So I'm going to bring that over to positive on the piezo board that we just had. And I'm going to connect ground on the piezo board back to the cable. I'm going to pop it into the top of the cable that's sticking out of ground on the battery board. So we can power two things at the same time just by stacking them up like that. And that would be something in a circuit that's called a node, where you have multiple things connected at one point. So banana cables allow us to make nodes with multiple connections to them. Okay, great. Well done. Let's see your first circuit.